Hello guys, we're going to be continuing from where we stopped the last time, and we're going to be looking at the additions and subtractions of vectors. Addition and subtraction for vectors. So this is what we are going to be considering. And when we talk about addition and subtraction of vector, now I'm going to be using a diagram to illustrate this. The diagram goes like this. We have the point here to be A, have the point here to be B, we have the point here to be C. And let's say AB is small letter P, while BC is small letter Q. This is going to be P plus Q. Now there's a reason why AC is P plus Q. The journey from A to C can be accomplished in two ways. That is, the journey from here to here, this is like this, can be accomplished in two ways. The first way is that I move from A to B, then also from C to C. So if I want to go from A to C, it's either I move from A to B, then from B to C. Or the second way I can accomplish this journey is directly moving from A down to C. So these are the two ways I can move from A to C. Now the vector AC is said to be the sum of AB and BC. That is, vector AC is said to be the sum of AB, which is vector AB, plus vector BC. Why? Because what AC can achieve is the same thing AB plus BC will also achieve. And as a result, we represent, just like I've represented AB as P and BC as Q. So it automatically means that AC is definitely going to be P plus Q. And that's the reason we have that our AC here is P plus Q, because I've represented AB with P and I've represented BC with Q. So putting them, substituting them into this, we have AC is what? P plus Q. So the law that AC is equal to AB plus BC, what I've applied here is a law that we called the triangular law of vector addition. Triangular law of vector addition. Triangular law of vector addition. That's the law we call it. A law that applies such that you have your AC, the destination from A to C, which is the same thing as the destination from A to B, then from B to C. Anytime we apply this law under vector, it is known as the triangular law of vector addition. And from the definition of a negative vector, we can now equally say the subtraction of a vector is the same thing as the addition of its negative vector. That is, let's say we have another triangle. Okay, let me write it this way. From the definition of a negative vector, from the definition, giving you definition before of negative vector. we can say that the subtraction of a vector is the same as the addition of its negative vector. I'm going to illustrate this very soon. So the subtraction of a vector is the same as you adding its negative vector. So according to the definition of negative vector. Now take for instance, we have a diagram, a triangle PRS. There is a triangle PRS. Then we have the midpoint of RS to be Q. So Q here is the midpoint of RS. Just like we have like this. Let's give value to the sides. So for PQ, let's give A. That is P to Q. That is, an object is moving from P down to Q. It means the movement is going to follow the arrow like this. And if I want to talk about moving from Q down to P, so it's definitely going to be negative of P to Q. Why? Because it is moving in the opposite direction like this. PQ is moving like this. Why QP now is moving in the opposite direction, and that's what makes its negative value of A. Now let us denote QR to be A. Okay, I've used A already. So let's denote QR to be B. So it means it is an upward movement from Q to R. Since QR is the same thing as QS, it means they are both going to be having the same value of B. But one thing that separates them is we are moving this time around from Q down to S, which is a negative value. That's the opposite direction. So automatically, QS definitely is going to be B, minus B rather. It will be negative B. Now let's quickly talk about the triangular law of vector addition. So in this case now, we have two different triangles. So which is triangle PQR and triangle PQS. Triangle PQR and PQS merged together because the whole triangle PRS has been divided into two using the line PQ in the middle. So let's quickly talk about triangle PQR. Now, if I want to move from P to R, that is PR, using the triangular law of vector addition, it's same thing as me moving from P to Q, then Q to R. So it's same thing as saying PQ plus QR. And don't forget, PQ has been denoted with A. So that means moving from P to R is same thing as saying A, then plus QR has been denoted with B. Because it's A plus B. Thus, I can equally say my PR moving from P to R is A plus B. Now I can do the same thing for the other triangle, that is triangle PQ and S. So if I want to move from P to S, I can equally say also P to S using triangular law of vector addition, is the same thing as moving from P to Q first and from Q down to S. So it's going to be PQ then plus QS. We have PQ then plus QS. Since PQ has been denoted with A and QS is denoted with negative B, thus I can say PS is the same thing as A minus B. So these two illustrations has given me or has demonstrated the sum and difference of two vectors. How we can illustrate the sum and the difference of two vectors. Now, suppose there are more than two vectors to be added. Suppose we have more than two vectors to be added, and this brings us to the addition of several vectors. Addition of several vectors. Addition of several vectors. That is, we have more than two vectors to add together. So let me quickly use a diagram for the illustration. Let's say we have triangle. We have from the starting point, we have P, Q, and R. So this is P, this is Q, and this is R. So R is having an extension. Now from R down to S. So we have PS. And also from S down to T. So we can also have PT. Then we could have from T down to U. It could be to infinity amount of size. It could be to infinity amount of size. So it doesn't really matter. But let's quickly consider P, Q, R, S, and T. So it's going to be the same thing when we are adding several vectors using vector addition. Now let's quickly consider PQ to QR using vector addition. We can say moving from P to R, that is PR, is equal to moving from P to Q first, PQ, then moving from Q to R. Don't forget, we just discussed the triangular law of vector addition. So if you want to move from P to R, now let's consider the movement from P to S. That is this movement. If I want to move from P to S, it's the same thing as me moving from P to R, then from R to S. P to R, then from R to S. So E also PS, the same thing as moving from PR, then plus R to S. Also, if I want to move from P to T, that is like this, it's the same thing as moving from PS, then S to T. So moving from P to T, the same thing as moving PS, then plus S T. Moving as PS plus ST. Now all we just need to do is, we already know that PS is PR, then plus RS. I already know. All we just need to do is put all this into the parameters that we have lastly. I believe you are getting what I'm saying. Since PR is the same thing as PQ plus QR. You can also put them into what we have last year. So since PS is the same thing as PR plus RS, hence our PT is, so instead of me writing PS here, I'm going to write a value PR plus RS. PT is PR then plus RS, then plus ST. Also, since PR, we have values for PR, and the values for PR, they are up here, which is PR is equal to PQ plus QR. Let's substitute PQ plus QR into PR here. Since PR is also PQ plus QR, so we can substitute the value of PR as PQ plus QR into this. Else we have PT equal to, so instead of using PR here, we're going to use PQ plus QR, then plus and plus RS, which is here, plus RS, then lastly plus ST. So as you can see, moving from P to Q in the diagram, it is like this. From P to T rather in the diagram, the same thing as moving from P to Q first, then from Q to R, then from R to S, and from S to T, as we have here. So it's PT moving from P to T is the same thing as moving from PQ, then plus QR, then from RS, then to what? Then to ST. So this is how we add several vectors together. Almost the same thing as the triangular addition of vectors. So the same thing as using the same procedure, the same concept in solving several vectors. So we are going to be looking at some examples so that we are going to see how these things are being applied. So in order not to make this video too long, I think we should look at these examples in the next videos.